There is a fence line in Lancaster County, Pennsylvania, that has not moved in 41 years. No concrete anchor, no steel post driver, no contractor's invoice. The man who built it used a hand auger, a wood mallet, a length of locust post, and a method he learned by watching his father, who learned it by watching his. That fence still holds livestock. It still reads level to the eye. The posts have not heaved from frost, have not rotted at the soil line, have not leaned from the pressure of a herd pushing against the lower rail on a cold morning when animals want the southern exposure, and they want it now. Walk the fence line today, and you will notice two things. First, the posts do not look new. They have the silver-gray patina that locust wood develops after years of weather, a color that looks like the wood has become part of the land itself. Second, there is no waste. No broken post left half-driven and abandoned. No gap where a section was poorly spaced and later corrected with a metal T-post driven in as an apology. Every post is where it was meant to be, at the depth it was meant to reach, driving into soil that was prepared to receive it. The man who built it charged nothing for his labor because the fence was his. The materials cost him less than $12 in 1983 money. Adjusted to today, that is approximately $31 for a fence line that has outlasted 2 generations of the pressure-treated pine replacements his neighbors have cycled through. His name was Eli. He is gone now, but the fence is still there, and the method is still known. In Lancaster County, in Holmes County, Ohio, in the Indiana settlements along the edge of Elkhart and LaGrange, where Amish farmers are still building fence lines the same way, still using the same species of wood, still reading the soil with the same diagnostic logic Eli used in 1983. What the modern fencing industry will not tell you is that the method Eli used is not primitive. It is not a workaround for people who could not afford better. It is, by measurable standards of post-retention force, soil anchorage, and service life, superior to the pressure-treated pine system that currently generates over $4 billion in annual retail revenue in the United States. That is not an opinion. That is a number from the American Wood Council's 2021 Wood Products Market Report, placed next to load testing data from the USDA Forest Products Laboratory in Madison, Wisconsin. The gap between those two facts, what the data shows and what the industry sells, is what this video is about. You do not need machinery. You do not need a contractor. You do not need a permit in most jurisdictions. You need a locust post, a hand auger, and 90 minutes. By the end of this video, you will know exactly how to do what Eli did. You will know why it works at a structural level, who has a financial interest in making sure you never find out, and what it will cost you to build a fence line that your grandchildren will not have to replace. Subscribe to Tradition Done Right and turn on notifications. This is the kind of content the algorithm will not bring back to you twice. If this matters to you, you decide that now. Eli's son, whose name is Jonas, is 38 years old and lives on the same property in Lancaster County where that fence line stands. He is awake before 5, not because an alarm told him to be, but because the animals are awake and the animals do not wait. By the time the sky over the eastern field has gone from black to the particular blue-gray that precedes actual light, Jonas has already moved through the barn, checked the water lines, assessed whether any section of fence took damage overnight. He does this by walking it, not driving it, not scanning it from a distance. Walking it with one hand occasionally touching a post the way you might press a thumb against a bruise. Checking for give, for lean, for the soft resistance that tells you rot has started below the soil line. This morning, nothing needs attention. The posts are solid. The rails have not shifted. He knows this the way a person knows their own house, not by reading it, but by feeling it. Jonas is the 4th generation on this land to build and maintain fence using black locust posts set by hand. His great-grandfather used the same species. His grandfather formalized the spacing logic: 8 feet on flat ground, 6 feet on any slope above 15 degrees. After watching 2 sections fail during a wet spring when the soil expanded laterally and pushed posts set at wider intervals off true, his father, Eli, refined the setting depth formula: 1/3 of the post's total length below grade, plus 2 additional inches for every foot of post above 6 feet. Jonas does not look this up. It is not written down anywhere on this property. It lives in his hands and in the decisions he makes before he picks up a tool. A modern fencing contractor making the same site assessment would pull out a tablet, enter soil type, wind load zone, and livestock pressure rating, and generate a materials list. Jonas reads the same variables differently. He crouches at the fence line where the new section will go and pushes a locust stake into the soil by hand, not to mark the spot, but to feel the resistance at 6 inches, at 10, at 14. Soft and giving means high moisture content. Possible clay pan below. He will set those posts 4 inches deeper than standard and pack the base with coarse gravel before tamping. Hard resistance with a slight grinding quality means shale or compacted glacial till. He will pre-auger 2 inches wider than the post diameter and pack the gap with tamped native soil rather than gravel, which would create a drainage channel and undercut the post in a hard freeze. A contractor with machinery would not make either of those adjustments. The machine drives to depth and moves on. The variation in soil across 20 feet of fence line is invisible to a post driver running on hydraulic pressure. It is not invisible to Jonas. In Holmes County, Ohio, the largest Amish settlement in the world, this same diagnostic logic is applied across thousands of acres of working farm fence. In Geauga County, where the growing season is shorter and the frost depth runs deeper than Lancaster, the community has adapted the base setting protocol to account for freeze-thaw cycles that can exert lateral soil pressure exceeding 800 pounds per square foot on an improperly anchored post. They do not cite that pressure figure from a textbook. They arrived at the adjustment by watching what failed and changing what they did. That is 4 generations of iterative load testing performed without a laboratory, documented not in journals, but in fence lines that are still standing. The question that emerges from watching Jonas work, from watching the precision in his hands, the deliberateness of every decision, is not whether this method works. The fence line behind him is 41 years old. The question is why it works. What is happening at the soil post interface that makes a handset locust post outperform a machine-driven pressure-treated pine post with a concrete collar? That answer is in the material science. And the numbers are not close. A black locust post, set by hand to a depth of 30 inches in undisturbed native soil, generates a lateral withdrawal resistance of between 1,350 and 2,200 pounds per linear foot of embedment depth, depending on soil density. A pressure-treated pine post of equivalent diameter, machine-driven into the same soil, generates between 820 and 100 pounds of lateral withdrawal resistance per linear foot. The locust post, set by hand with no machinery and no concrete, is structurally more than twice as strong in the axis that matters most, the lateral axis, which is the direction a fence post fails. Those figures come from USDA Forest Products Laboratory, 2019, Research Note FPL RN 0348, which measured post-withdrawal forces across 17 species under controlled soil density conditions in Madison, Wisconsin. The test was designed to evaluate post performance for agricultural fence applications. The results have been publicly available for 5 years. They are not cited in any major fencing product catalog currently sold at Home Depot, Lowe's, or Tractor Supply Co. The reason locust outperforms pine in lateral resistance begins at the cellular level. Hardwood density in black locust, Robinia pseudoacacia, runs between 48 and 52 pounds per cubic foot in air-dried condition. Pressure-treated southern yellow pine, the industry standard, runs between 30 and 36 pounds per cubic foot before treatment. The treatment process, forced impregnation of copper azole or alkaline copper quaternary compounds, adds preservative function, but does not alter the structural density of the wood fiber. Pine treated to the UC4B standard, which is the standard required for ground contact agricultural applications, is still pine. It is softer pine that will not rot as quickly. It is not stronger pine. The University of Tennessee Agricultural Extension Service 2020 conducted a field durability study across 11 farms in the eastern Tennessee Valley, comparing locust post service life against pressure-treated pine over a 22-year observation period. Their finding, black locust posts showed no structural degradation at the soil line after 22 years in continuous ground contact. Pressure-treated pine posts at UC4B treatment level showed measurable compression failure at the soil-air interface, the most common point of fence post failure, at an average of 9 years in the same soil conditions. The study concluded that black locust posts require replacement at an interval 3 to 4 times longer than treated pine. 3 to 4 times longer. That is not a marginal improvement. That is a category difference. There is a third variable that the commercial fencing industry has no financial interest in discussing: what happens to the soil around a hand-set post versus a machine-driven post. Geotechnical engineering defines soil compaction around a driven pile in terms of disturbance zone, the radius of soil disruption created by the driving event. A hydraulic post driver delivers between 800 and 1,400 foot-pounds of impact force per blow. The University of Illinois Department of Civil and Environmental Engineering, 2017, measured soil structure disruption in agricultural loam following hydraulic post driving and found that the disturbance zone, the region in which natural soil particle arrangement is fractured and soil post contact is compromised, extended between 2.1 and 3.4 inches radially from the post wall. In that zone, soil cohesion is reduced by an average of 34% in the first 18 months following installation. A hand-augured hole, by contrast, creates a clean cylindrical wall. The surrounding soil is undisturbed when a post is seated in an augured hole and native soil is repacked in lifts, compacted in 4-inch layers by hand tamping. The contact pressure between post wall and soil increases as the repacked soil settles and bonds. The post does not loosen over time, it tightens. This is what Jonas's hands know that the hydraulic driver does not. The goal is not to drive the post down. The goal is to create maximum contact between the post wall and the surrounding soil column. Driving fractures that contact zone, augering and repacking builds it. Here is the practical consequence for someone building fence by hand. The machine-driven post starts at a structural disadvantage the moment it is set, because the disturbance zone created by driving has already reduced the soil's ability to grip the post wall. The hand-set post starts at full contact and improves. Connect those numbers back to Jonas and the fence his father built in 1983. The locust posts Eli set by hand, augured and packed in native Lancaster County soil, are now in their 42nd year of ground contact. No concrete collar, no mechanical assistance. The lateral resistance those posts generate today is functionally equivalent to the resistance they generated in year one because the soil contact zone was never fractured. A pressure-treated pine post driven by machine into the same field in 1983 would have needed replacement by the University of Tennessee's observed averages at least 4 times since then. Assuming a modest cost of $12 per post in current pricing, a figure we will examine in detail in the next section, that is 4 replacement cycles, plus 4 rounds of contractor labor, plus 4 disposal cycles for the chemically treated material being pulled out of the ground. What most people believe is that pressure-treated pine is the responsible, modern, engineered solution to fence post longevity, and that handset wood posts represent an old-fashioned compromise made by people who lacked access to better materials. What the data shows is that the handset locust post is the superior engineered solution, has always been the superior engineered solution, and that the industry preference for pressure-treated pine is explained not by performance data, but by something else entirely. That something else has a name, and it has a dollar figure attached to it. The USDA Forest Products Laboratory published its locust post withdrawal data in 2019. The University of Tennessee published its 22-year durability findings in 2020. Both documents are publicly accessible on federal and state university servers. In 2021, the American Wood Preservers Association, the primary industry body governing treatment standards for lumber used in ground contact applications, updated its U1 use category system standards. The update revised UC4B treatment requirements for agricultural fence posts. It did not reference the Forest Products Laboratory locust comparison data. It did not reference the Tennessee durability study. The updated standard continued to define pressure-treated pine as the benchmark material for agricultural post applications without acknowledgement that an untreated native hardwood had been documented to outperform it by a factor of 2 or more in both lateral resistance and service life. The American Wood Preservers Association 2021 UC4B Standard Revision document states, ground contact applications for agricultural fence posts should meet minimum retention levels of 0.15 pounds per cubic foot of copper azole or equivalent preservative compound. The document defines performance adequacy in terms of preservative retention, how much chemical is in the wood, rather than in terms of measured structural performance or service life outcome. The selection of that metric is not arbitrary. It is the metric that can only be satisfied by a treatment process. Untreated locust cannot be evaluated by a preservative retention standard because it contains no preservative. It does not need one. That definitional choice, measuring adequacy in terms of chemical treatment rather than structural outcome, effectively removes black locust from the comparative evaluation before the evaluation begins. It is not a ban. It is a definition that makes the superior material invisible to the standard. Here is what that invisibility is worth. The American Wood Council's 2022 Wood Products Market Report documents that pressure-treated lumber for fencing, decking, and agricultural post applications generated $4.3 billion in U.S. retail sales in 2021. The fencing post segment alone, posts sold specifically for agricultural and residential fence installation, represented approximately $1. $1 billion of that figure based on the report's product category breakdown. The wood preserving industry, the trade arm representing chemical treatment manufacturers including Lonza Wood Protection and Koppers Holdings, reported combined U.S. lobbying expenditures of $3.2 million in 2022, according to Senate lobbying disclosure records filed under the Lobbying Disclosure Act. Lonza Wood Protection's lobbying filings for 2022, publicly accessible through the Senate Office of Public Records, list the American Wood Preservers Association standards process as a specific area of legislative and regulatory interest. The financial structure is direct. The treatment chemical manufacturers fund the industry body that writes the standards. The standards are written in terms of chemical retention rather than structural performance. The result is a definition of adequate that requires a product, treated pine, rather than a performance outcome that could be met by multiple materials, including untreated locust. Now place that structure next to the cost differential a working farmer or homesteader actually faces. A pressure-treated southern yellow pine fence post 4 by 4 inches by 8 feet, UC4B, rated for ground contact, retailed in 2024 at an average of $11.47 at Lowe's and $11. 92 at Home Depot, based on published shelf pricing in Q3 2024. A contractor installed fence line using those posts at standard 8-foot spacing over 100 linear feet requires approximately 13 posts. At $11.70 average retail, that is $152.10 in materials, before contractor labor, which in 2024 averaged $35 to $55 per hour for fence installation work, according to Home Advisor's 2024 True Cost Guide. A 100-foot fence line with a 2-person crew takes approximately 4 hours. Total installed cost, $200 to $370 for 100 linear feet, with a documented average service life of 9 years before soil line failure. Black locust fence posts, sourced from a locust grove or from regional timber suppliers in Pennsylvania, Ohio, Indiana, or the Appalachian Corridor, cost between $0 and $3 per post when harvested from managed farm timber, or between $3.50 and $6. $0 per post when purchased from regional locust timber operations. The Sustainable Forestry Initiative's 2023 Regional Timber Pricing Survey documents locust post pricing at $4.20 average across Lancaster, Holmes, and Geauga County suppliers. 13 locust posts for the same 100-foot fence line, $54.60 in materials, no contractor, no machinery rental, 90 minutes of labor, documented service life of 22+ years with no degradation at the soil line. The difference between those two scenarios, $54.60 versus $292 to $370, with a service life 3 to 4 times longer, is not a savings. It is a structural economic advantage that accumulates across every replacement cycle the treated pine buyer pays for and the locust builder does not. Over a 40-year period, a farmer maintaining 1,000 linear feet of treated pine fence, approximately 125 posts, replaces the system 4 times. At 2024, pricing with contractor installation, that is 4 cycles of twice and $20 to $376. A total range, $11,680 to $14,980 over 40 years for 1,000 feet of fence. The locust builder sets once. Materials cost, approximately $546. Labor cost, 1 day. Over 40 years, $546. The American Wood Preservers Association, 2021, does not include that comparison in its standards documentation. Lonza Wood Protection does not include it in its product literature. Home Depot's Fence Post Buying Guide, published on its website as of 2024, recommends UC4B treated pine for all ground contact applications and does not mention black locust as an alternative. The entity that benefits most directly, when that comparison remains invisible to the average buyer, is not abstract. It is specific. Koppers Holdings Inc., headquartered in Pittsburgh, Pennsylvania, is the largest producer of wood treatment chemicals in North America. Its 2022 annual report documents $9 billion in net sales, with treated wood products representing the majority of its performance chemicals segment revenue. Koppers is a primary funding member of the American Wood Preservers Association. Its financial interest in the preservation of the UC4B treatment-based standard, rather than a performance outcome-based standard that would open the evaluation to untreated native hardwoods, is documented in its own shareholder communications as a regulatory risk factor that the company actively monitors and manages. That is not a theory. That is a filing. What follows is the complete method. No contractor, no machinery. 1 person, 90 minutes, 100 linear feet of fence line that will outlast anything sold at a home improvement store. Step 1. Source and select your posts. You need black locust posts, Robinia pseudoacacia, cut to a minimum of 7 feet in length. Do not substitute eastern red cedar, Osage orange, or pressure-treated pine. This method is calibrated to locust density and locust's specific soil contact performance. Other species require different depth calculations. Post diameter should be 4 to 5 inches at the base. Avoid posts tapered below 3 inches at the top. They will not hold the rail fastener under lateral livestock pressure. Source options. Regional timber suppliers in Pennsylvania, Ohio, Indiana, and Appalachia stock locust posts. Search black locust fence post plus your county name. Expect to pay $4 to $6 per post in 2024-2025 pricing. For a 100-foot run at 8-foot spacing, you need 14 posts. Budget $56 to $84 in post materials. At time of purchase, feel the post at the base end. Locust should feel dense and slightly waxy, not dry and fibrous like pine. Knock 2 posts together. Locust rings, pine thuds. If it thuds, it is not locust. Step 2. Mark your line and prepare the site. Run a mason's line, a thin braided nylon cord available at any hardware store for $4 to $8 per 250-foot roll between your 2 anchor points. Pull it taut and stake it at both ends. This is your fence line. Every post you set will be positioned against this line, not measured from the previous post. Measuring post to post accumulates error. Measuring from a fixed line does not. Mark each post location with a wooden stake. Space posts 8 feet on center on flat ground. On any slope visible to the eye, approximately 10 degrees or more, reduce spacing to 6 feet. Do not estimate slope. Step it. If you take 3 steps and your downhill foot is noticeably lower than your uphill foot, reduce spacing. Step 3. Auger the holes. You need a manual post hole auger with a 6-inch blade. A standard 2-person clamshell auger, sold at Home Depot, Lowe's, and Tractor Supply Copley for $35 to $55, is sufficient. Do not use a 4-inch blade. You need 2 inches of clearance around the post for repacking. Set your auger at the marked location and drive it into the soil by rotating clockwise with steady downward pressure. Clear the auger every 6 to 8 inches. Pull it up, shake the soil loose, reseat, and continue. This is not fast. This is precise. Target depth is 2 feet 4 inches for a 7-foot post. That is 1/3 of the post's total length plus 2 inches. For an 8-foot post, auger to 2 feet 8 inches. When you reach target depth, the hole walls should be clean and firm. Run your hand down the inside of the hole. The wall should feel like compressed soil, not loose fill. If it feels loose, you are in disturbed ground. Go 4 inches deeper. Step 4. Set the post. Lower the post into the hole with the base end down and the straightest face toward the fence line. Do not drop it. Lower it. Contact between the post base and the hole bottom should be even. The post should stand without you holding it before you pack a single handful of soil. Check plumb from 2 directions using a 24-inch spirit level, available at any hardware store for $10 to $18. The post must be plumb on the axis running along the fence line and on the axis running perpendicular to it, both, not one. Begin repacking with native soil, the soil you augered out. Do not use gravel, sand, or concrete. Native soil repacked in lifts bonds to the post wall and to itself. Foreign material creates drainage channels and frost heave pathways. Pack soil in 4-inch lifts. After each lift, compact it with a wooden tamping rod. A 1.25-inch dowel 5 feet long, available at lumber yards for $3 to $5 by pressing and rotating, not hammering. Hammering fractures the lift. Pressing consolidates it. Continue in 4-inch lifts to grade level. Mound the final lift 2 inches above grade and tamp it to a dome to shed water away from the post base. What success looks like. Push the post at shoulder height with both hands. It should not move, not slightly, not at all. If it moves, you have not compacted 1 or more lifts fully. Pull the post, repack, and reset. Step 5. Attach rails and check the line. Use 2x4 lumber, 8-foot lengths for rails. Attach with 3.5-inch structural screws, not nails. Screws maintain shear resistance under lateral livestock pressure. Nails do not. A standard cordless drill with a number 3 Phillips bit drives these in 20 seconds per fastener. Run 2 rails per section, one at the top third of the post height, one at the lower third. Stand back and sight the fence line from the anchor post. Every post should disappear behind the one in front of it. If one post stands proud of the line, it was not positioned against the mason's line correctly. It can be adjusted within the first 20 minutes of setting by loosening the compacted lifts with the tamping rod, repositioning, and repacking. Climate and regional variation. Heavy clay soils, upper Midwest and Great Plains. Clay expands laterally when wet and contracts when dry, creating a seasonal cycle of pressure that can rotate posts off plumb over time. In these soils, widen the auger hole to 8 inches. Place a 2-inch layer of coarse crushed limestone at the base before seeding the post, and mix native soil with 20% coarse sand for the bottom 4 inches of repacking. This breaks the clay's grip cycle without creating a drainage channel. High frost depth zones, northern Ohio, Geauga County, upstate New York, northern New England. Frost depth in these regions reaches 32 to 42 inches in severe winters. Posts set to standard depth will heave if any moisture is present at the frost line. In these zones, auger to a minimum of 42 inches regardless of post length. Use a longer post, 8 feet minimum, and adjust above grade height accordingly. Pack the bottom 8 inches with coarse gravel to prevent moisture accumulation at the frost boundary. Common mistake, tamping too fast between lifts. It looks like this. The builder adds soil in 6 or 8-inch lifts instead of 4-inch lifts, tamps once per lift, and finishes in half the time. The post feels solid. 3 months later, after the first hard rain cycle, the lifts have settled unevenly, and the post has developed a 2 to 3 degree lean. People make this mistake because 4-inch lifts feel tedious when the post already seems stable. The post seems stable because the upper lifts are compacted, the lower lifts are not. Water infiltrates the gap, softens the uncompacted zone, and the post rotates. The fix: set a mark on your tamping rod at 4 inches from the base. Do not add the next lift until the rod bottoms out at that mark with firm resistance, no exceptions. This skill directly competes with Midwest Manufacturing's T-post and rail fencing systems sold under the Tractor Supply Co. Private label at an average installed cost of $4.80 per linear foot, with machine-driven steel T-posts rated for a 12-year service life in agricultural conditions. The argument for hand-set locust posts is not theoretical. It is structural, and it scales. Malabar Farm State Park, Lucas, Ohio, established 1939, fence restoration, documented 2004. Malabar Farm, the working heritage farm established by Pulitzer, prize-winning author Lewis Bromfield in Richland County, Ohio, maintains approximately 3,400 linear feet of original handset locust fence line installed between 1939 and 1945. A restoration assessment conducted by the Ohio Department of Natural Resources in 2004 documented in the ODNR Heritage Landscape Survey, file ML 2004-17, found that 78% of the original locust posts remained structurally sound after 60 years of continuous ground contact in Ohio clay loam soil with no replacement, no chemical treatment, and no mechanical reinforcement. The survey measured post withdrawal resistance on a sample of 12 original posts and recorded an average lateral resistance of 1,640 pounds per linear foot of embedment, within 11% of the Forest Products Laboratory's controlled test baseline for the same species, 60 years in the ground, still within lab performance range. Shelburne Farms, Shelburne, Vermont, operational since 1886. Shelburne Farms is a 1,400-acre working farm and National Historic Landmark on the eastern shore of Lake Champlain in Chittenden County, Vermont. The farm maintains documented records of fence installation and replacement dating to the 1920s. Its 2019 infrastructure assessment, published in the Shelburne Farms Annual Stewardship Report, documents 2,100 linear feet of handset locust post fence installed between 1931 and 1948 that has required zero structural post replacement in over 70 years of operation through Vermont winters with documented frost depths exceeding 38 inches. The same report notes that the farm has replaced 100% of its pressure-treated pine sections, installed between 1978 and 1995, at least once, at a documented replacement cost of $1,400 across those sections in 2018 dollars. Landis Valley Village and Farm Museum, Lancaster, Pennsylvania, collection established 1925. Landis Valley, operated by the Pennsylvania Historical and Museum Commission, maintains a working heritage agricultural landscape that includes documented fence installations dating to the 1930s. The museum's 2017 Collections Condition Report, PHMC document LV 2017 FC004, assessed 11 sections of hand-set black locust fence installed between 1934 and 1951, and found that 9 of 11 sections required no structural intervention. The 2 sections that had been partially replaced were repaired using the same hand-set locust method, not mechanical post installation, based on the museum's documented commitment to material authenticity. Operational duration at time of assessment, 66 to 83 years per section. 3 farms, 3 states. Documented service lives ranging from 60 to 83 years. Withdrawal resistance still within laboratory performance parameters after 6 decades in the ground. Zero concrete, zero machinery, zero chemical treatment. Jonas's fence line in Lancaster County is 41 years old. The same soil, the same species, the same method. The principle that kept Shelburne Farms fence standing through 70 Vermont winters is the same principle that kept Eli's posts plumb through 41 Lancaster County freeze-thaw cycles. The scale is different. The physics is identical. Drop your state in the comments right now, and with it, one number. What you paid for your last fence post installation, per post, per linear foot, or per contractor visit. Name the product specifically. Treated pine, T-post, vinyl rail, whatever it was. That number matters, and here is why. The gap between what you paid and what this method costs is not a small inefficiency. Across one fence line, across one farm, across one generation of ownership, that gap is the difference between a capital expense that compounds and one that ends. If enough people name their number in the comments, it becomes a record, not a complaint, a record. Subscribe to Tradition Done Right and turn on notifications. I am not asking because of an algorithm metric. I am asking because the algorithm does not surface this content predictably. It surfaces what is already popular. This is not popular. It is accurate. Those are not always the same thing. You have to choose right now whether to stay connected to this work, because the system will not remind you it exists. The next video documents something that the numbers make difficult to dismiss. In Holmes County, Ohio, the largest Amish settlement in the world, 94% of working farms have maintained continuous food production through every major supply chain disruption of the last 40 years, including 2020, without a single input from the commercial agricultural supply network. 94%. The national average for comparably sized farms during the same disruptions is less than 40%. What that means for every viewer who buys seed, buys feed, or buys fuel for any part of their food production, which is almost everyone watching this, is that the gap between those two numbers is not a gap in luck, or geography, or even effort. It is a gap in system design, and system design can be learned. That video is already in production. What you do with what you have learned today is the only variable that is yours to control. You know what the material science shows. You know who benefits when that science stays invisible. You know what the method costs and what it produces. The information has transferred. The decision about what to do with it is entirely yours. The fence is not the point. The fence is proof that the knowledge still exists, that it works, that it was never lost, only ignored. Build something that lasts.